Okay, so here we go. Just had a quiz. We needed to have a better percentage than that 7th hour. Rough. Anyway, look up here. So you just got yelled at online. That was all review, and I got 53%. I don't know what's happening in this room. All right, a zero or a root turns into an x-intercept. We're hitting some terms that are, I guess, considered synonyms. And then when I have a zero for an equation, it turns into a linear factor that looks like this. Remember, it's always the opposite thing. So if it's x minus 2, 2 comma 0 is the x-intercept or the 0. All right. So I'm going to do this real fast. This is where we're going now. We're moving on a little bit from quadratics to cubics, but the factoring is not that bad. Okay, first thing you have, and I don't want to waste time on this, just watch and learn and listen. You will have to do this in college, but you should know, I don't know why I made that a 4. That was a brain glitch. You should know that now we can take out a GCF. So that's how we're turning quadratics into cubics. All right, but then analyzing what happens with the picture. All right, and then one more factor. This is x minus 4, and then x plus 2. What multiplies to -8 and adds to -2. Correct. Okay, now that's why I see what I see here. This 0 is 0, 0. I think up there it says state the multiplicities, does it? Write each function in factor form. Identify all the real zeros. And these are all mult ones. We talked about multiplicities, I believe, but maybe not. Maybe I'm thinking of the other class. So those are just, yeah, I think we're just beginning that with you guys. Sorry. Sometimes the classes get a little run over in my head here. And there's where those zeros are. So we can see that. And we know that this is the expectation of the graph. This is what you're going to have to know. You're going to have to know that this is an x cubed, which should look like this. And then through factoring, these are the 3 0/x intercepts. And then you should be able to make a sketch from that. That's ultimately what the notes are today. All right. So take a look at that. It all coincides. Everything looks good if that really is the picture of that, which it is. Okay, but then the next one, it's very similar, but I have an x squared I can take out. Then it leaves me an identical quadratic is what this is called, which factors identically, x minus 4, x plus 2. But then we got something special. 4 comma 0 is a mult 1. So it's multiplicity 1. Look at 4 comma 0. This goes through and it looks like a line. And that's what we want to think. A multiplicity 1, a regular 0 with no other degree than 1. And there is a 1 there. I had someone confused about that in tutoring. Yeah, you could say that's raised to the 1 power on that factor. That just means that's its multiplicity, which is a term we're going to use down there. Goes through the graph linearly. Same thing with -2 comma 0. If you zoom in on this, this does go straight through like a line if I could get further on it. I know it's curved a little bit, but nothing special. It just kind of goes straight through that 0. And that's what happens. But then lo and behold, look at this special 0, which you're going to find out down there, 0, 0. Don't screw this up. That's 0, 0 as a 0. That's a lot of zeros in my mouth there. Is a multiplicity 2. And that goes through, honestly, like a, let's not say quadratic, it looks like a parabola at that little position. And I wish I could zoom in further, but just like if I just look right here to here, it hits through parabolic, like a parabola right there. Why below? Because of where it's coming from. I hope everyone knows that some people are just staring outside. What a beautiful day. I can't wait to be out there. Okay? Yeah. Housefly. All right. Bzz. Okay, so that's the differences that we see with the two graphs. Teaching in America. All right, so linear factors, representative of that, can have multiplicities. The multiplicity of the 0 is the degree of the factor. All right, so put that word in there so you're focusing. The degree, so the power on the parenthesis. Okay, so this is how we're going to list the zeros. Notice we don't list multiplicity 1, but when the multiplicities change, then we will state their multiplicities. Then we're supposed to know what they look like in the graph. And I do believe, go get your graphing calculator out. I forgot, yes. So get your graphing calculator out. And this is good I'm my calculator right now is from when I was in honors, so I do have to set this up here. So I'm gonna hit second quick. All right, those that have your calculator out, I got to make sure I'm kind of speaking this way. So, but I'm going to move to the screen here.
We clicked
Okay.
what?
Nothing yet. Okay, so I'm going to do this first so that your calculator's in good shape. Try to have this so you can see the screen as I'm in the class, and I can type on the board here. We want to all do the same thing here because when I try to go to y equal, hit y equal real quick, you may have some stuff there. I've done this all day long, by the way. I've shown, and this is bad because now I can show you how you can be a jerk to a friend. Every day I go to the calculator, every time in a class period, at least one out of every 2 classes, a kid raised their hand and said, I'm getting an error. I cannot graph. Watch this. Sabotage yourself, negative, plus, times. These are all illegal parameters in the y equal screen. I shouldn't even show you this. But because that's there, and even if I just wanted to graph the line, what the heck just happened there? Second quit. Okay, y equals. Even if I put 3x there, like I'm trying to graph y equals 3x and hit graph, the reason the graph won't stay is because of what's in y10. So I find this all the time. I find it fascinating. I feel like some people are being jerks and doing this to your calculator. So how can I get rid of it? I can go all the way down and delete it, or we should all do this right now. Hit second and do this like 5 times. Second mem, you may know what I'm doing next, because if you used your graphing calculator last year, this is what I would do to your calculator on the day of a test. Then I hit 7, which is reset, all RAM 1, and then yes, reset 2. So I'll do it one more time. Second mem 7, 1, 2. Let's do it again. Second mem, because there's always people lagging behind. And one kid in my honors, he's driving me nuts, comes into tutoring and he doesn't know how to do anything that I did in class. Nothing. Wouldn't even know how to do this. I don't know what he's doing at his desk when I'm teaching. It's driving me nuts and crazy.
Second
right?
plus
Oh my
second,
gosh.
1,
Okay.
2.
Are you asking or no? Okay.
Second plus 7, 1, 2.
Okay, great. Let's move on. All right, so here we go. Now we should be able to graph. And then this is what we're going to do. Hi, Karoba. Okay, we're going to go ahead and type this example in right here, this negative 0.01. And then what's funny is sometimes students are like, wait, where am I at? Where am I going? If you don't have a graphing calculator, you're doomed. All right, so 0.01. So you have people sitting there doing nothing again. Maybe they just do nothing. I don't know. You do nothing, you get nothing. Plus 4, and then it's just a regular 0. Ah! Do you see my mistake there? That'd actually be an x squared there. That would change the graph. Delete. I don't know if you can see how small that was there, that mistake. And then careful on this. X plus 1. Can't say I'm going too fast here. And then you got to do the caret button, that's the exponent button right there. And be careful. I'm annoyed by this. I hit third power, then it stays up there. I always forget that. Then I start doing the next parenthesis, and it's still all up in the exponent. So I got to get out of that, and then do x minus 3, and then do the squared button. That's a better one because it is squared, and then it squares and then gets out, and it's not in the exponent anymore. So anytime you have a chance for a square, do that. All right, so anyway, you should have that typed in and looking exactly like that. Okay, now you did hit second mem 712. So hit window real quick and just see that your window does say 10 to negative 10, both x and y. We're gonna have to manipulate this, okay? And I'll show you where in a minute. There's a couple things we can do because I'm gonna hit graph, and actually I'm kind of okay. Never mind, this is a future one. Maybe I'm thinking of the other class. I think it was the other class, the BCers. I got everything I need to see. And actually, that is the expectation. And this is what I mean about expectation, what you're supposed to know already. I don't know why this pen does not minimize, and then I just minimize both. Okay. This is an x cubed times a squared times an x. So this is an x to the 6th. and the leading coefficient would be negative 0.01. So polynomial dance, x squared, x cubed, negative x cubed. I think I just switched those. No, I did not. Okay. Blah, blah, blah. Negative x to the 6th should have some sort of behavior in the middle, but definitely end down and down. So when I look at my picture, and if you don't have the same picture, you did a mistake in your factors. That's exactly what you should see because we all did the same thing beforehand. Okay, now what I really want you to see, okay, is, again, there we go, it did go. I do have that sketch over there. But I guess I could have changed some things. I did in fourth hour or first hour, actually changed my window. Let's go ahead and do that just so you know how to change a window on a calculator. So go back up to here, hit window to match that picture on your sheet of paper. That window was from -5. Actually, it's probably more so like -6 to 6. But I'm going to go -5 to 5. No, I think I'm thinking of something else. And then it looked like the y's. Let me go back to this here. Where are the y's? -4 to 4. So that's how I can do this on this window. And then it should be almost exactly the same looking picture. -4 to 4. Whoops, I said 4 and I definitely hit 5. Graph. All it does is zoom in on a little bit more and then it matches the screen that you have. In honors, BC, we had to change the windows to get more. We had to change Y to 500 to -500, and that's coming for you guys. Sometimes the x-intercepts are farther than 10 to -10, so you got to expand the x's. So it's always in window that can happen, that you can manipulate the highs and lows. Don't worry about all the other stuff. I usually keep the scales by ones. That just means the tick marks go by ones on the x and y axis. And don't worry about this other stuff. It doesn't really apply to you right now. Okay, so I just want to make sure we're there. Okay, it does go down. All right, so list the zeros and the multiplicities. I want you to notice this one right here. Okay, but let's take them in order. Let's take that 4, x plus 4. That's -4, comma 0. Please stop doing that with the pencil, whoever's tapping. Always got all these things in 7th hour. Multiplicity 1. Look at that. Sorry, I'm going to write this down. It does go through like linear. It looks like a line. I like saying that term. When I zoom in on this, this just goes right. If I just looked at this and no other part of this graph, it looks like a linear situation through that point. It just goes right through with no character. Let's just leave it at that. Then let's go to the cubic one, which is -1, comma 0. Notice what I said there. That's multiplicity 3. We need to know that that looks like a cubic. I actually put this on second hour's notes. It looks like a point of inflection. In fact, it is right at that 0. It's where it changes concavity. So notice this. Okay, so, and I'll show you how to graph this on a later one, but this is literally concave down or concave up. So it's concave up here, then it changes the concave down here. So I'll show you how to graph that. It's just like graphing a cubic. The parent function for a cubic, I know that's going the wrong direction, but y equals x cubed looks like this. It goes like this, flattens through, and then goes through like that. You've got to show that flatness on a multiplicity 3, 0. Got to. Then on a double 0, which we just saw in our previous one, 3, comma 0, that mult 2 is actually like, I was going to put quadratic, but I want you to think of a parabola. It kind of looks like a parabola at that point. And then why is it below? It's just because of how the end behavior looks. But right here, that's what happens. I know what I want to put. What it is to the x-axis is tangent. Can everyone say tangent? That's tangent to the x-axis at this 0. It bounces and stays below just because of how the end behavior works. And that's it, but we're going to practice it. All right, that's what the notes are. You need to understand that this is how graphs look. So it might require some factoring in order to get it in factored form and then analyze where the x-intercepts are and then understand the end behavior. So it's all the things. This is why the class builds and you need to be keeping up with it. So why not doing homework is an absolute abomination. All right. Okay, so looking at this first one, this is how we emulate this, and then we got some tough ones here. And we're doing okay on time. But this first one is not. And I know it says this, like state all these, determine the degree of the polynomial. We're going to kind of scratch this all over. I don't have time to write everything down. But if I were to multiply this out, it'd be an x cubed times an x times an x squared. So what would the ultimate degree of this be? X to the what? 6. What would be the leading coefficient? 1, 1, 1 squared root of, oh, what would the leading coefficient be?
-2.
-2. I'm not wasting time on this. If you don't know this, you are severely and totally behind. Negative x to the 6 is n down and down. That's why you got to think about this first. Then you can think about the zeros. I'll kind of slip these in here real quick. This one, 0, 0. Don't be a goofball and say -2 comma 0 is a 0. No way. That's just the leading coefficient. This has mult 3. And it just is what's going to happen with that graph. Either listen or you don't. Either do it or you don't. It's a choice. And then -1 comma 0. That's a mult 1. You should never really have to write that. And I won't. Okay, and you really shouldn't have to. And then 4 comma 0 is a mult 2. All right, so that's multiplicity 2. That's a parabolic kind of situation, a bouncer. You can use the term bounce, it's fine. I'm not going to stick you to math terms here. 1, 2, 3, 4 comma 0, 0, 0, and then -1, 0. Fine. Now, all you're doing is a sketch. I just got the graphing calculator out with you just to see and just get the familiarity of typing on the calculator, but just to see the zeros too and their behavior. And actually, the calculator says so, so we believe it more. But here we go. 1 is, okay, so I got to have this end behavior happen. So I got to have this. I got this in my head that the ends go like this, down and down. And this is the last 0. Now, this is a regular 0. So this is my linear 0. Just goes right through. Okay, it just goes right through. So that looks like a line a little bit, even though there's some curvature. Now, the next 0. Watch how I do this. You ready? I'm zooming in. This is a mult 3, 0. So I want to come down here. That's already thrown me off. Look at where I started going. I'm left of that 0, coming down like a parabola in this case. Then I can flatten out in a nice curve like this and get that cubic behavior. So come there a little bit early to the left and then flatten out and then go through. And then that is concave up, and this is going to be concave down if I continue this behavior like that. So concave up a little bit, concave down definitely. So that is a point of inflection, so it looks like a cubic when it comes through. You don't do that, I'm getting you. All right, and then the last one is a double 0, so all I have to do, and you don't have to worry about how low this goes, but what you do have to worry about is get this to be tangent. And then notice how we started the zeros and followed the 0 behaviors. I did end the correct way. And that will happen as long as you got the right amount of zeros and the right multiplicities identified. Okay? This is your job. This is what you got to do. This is what you got to figure out. Problem is, I don't have time for this. Problem is, this one's a little bit different. Okay? So we will say what the end behavior is, but we'll do these quicker. What is x squared minus 4? What is that as a factored polynomial? X what? Yeah. Okay, I guess that was weird. I guess I went a little too long there. And then this is a quadratic or a 4th power 0. Gosh, I'm sorry we're so late here. By the way, what does that mean? X minus 4, x minus 2 is actually a degree of a 0. What is its multiplicity if I found another one? Okay, so it's x minus 2 to the 4th, but then I found another one. So what is it? Just say that number. What's 4 plus 1? 5. Okay, so that's a multiplicity 5. So 2 comma 0 is a mult 5, 0. Can't believe I ran out of time. Bad time management. So 1, 2 comma 0. And then this is 1, -2 comma 0. Now listen, mult 5, sorry, lost track of time here, is just like a mult 3. A mult 4 is just like a mult 2 multiplicity. So this is still a cubic, and this will, what will this end up being? An x to the 6, but 3. So this will end up and up. So this will go down through normal, and then this goes through like a cubic. So this flattens out and goes up like that. So this turned into a multiplicity 5, 0, which is just like a multiplicity 3. This is really the main idea. When the bell rings, I'm actually going to keep doing this as you put your stuff away. I'll talk about complex zeros at the end, and it should be less than 4 minutes on the video for notes. But you are going to be expected to know what happens with zeros that are imaginary. In fact, I can tell you real quick as you're putting your stuff away. You know, when you get an imaginary number in the quadratic formula, that means that's a parabola that does not cross the x-axis. So you already know this. So what you might just want to see is what I talk about with conjugates for like 3 minutes and how a graph might look when it has imaginary zeros. All right, that's what I'm going to do at the end. Okay, so you guys go ahead and leave. I'm going to keep going with this video. And you might want to watch C as well. This may take a few minutes. Take it easy. First thing is you got to factor this. You got to factor this. Take out a GCF, and then I'm going to put this right below here. Uh-oh, yeah, what's up?
What did I do wrong? It's not working.
You should ask me, turn the notes, or paid attention. That I did like 3 examples.
I know. I did.
You're
I
killing
did
me.
everything wrong.
Did you do this? Oh my
I
gosh.
did the thing 3 times.
Did you like do this? Then that. It's not even going down. I'm gonna cry if you have. Okay.
I have nothing. I did this thing you told me to do.
You have a
3
syntax. You
times.
probably did plus instead of minus, or you probably did negative sign instead of. That's a minus sign. You're supposed to
There
put a
is a-
negative.
Oh my god!
That was
I
it.
didn't see that.
Yeah. I'll see ya. Okay, that's what it was. Okay, and then this is, sorry, we had to see that. We had a whole thing about the calculator for like 20 minutes. Mine didn't work. All right. All right. Okay. Well, I'm doing a note thing. What? I'm so popular. Jeez. Yeah, what's up? Huh? I'm doing a YouTube video right now. No, get out. Get out. No, go away. I mean, I love you, but leave. Okay. All right. So that's a double 0. So at 3, 0, I'm going to mark that with the yellow. All right. It happened in 2 different parts here. And then this is a 0 regular, 0, 0. And then -2, comma 0. Hopefully this doesn't. And then 4. Oh, that stinks. These are really close. Okay. But I have that in yellow because that's a double, because it happens twice in 2 different parts. So again, going over this real quick with some goofballs coming in and interrupted my movie. I factored that first one and then got them all in factors, right? So this shouldn't be hard. It's just taking like the quadratics and just extending it further, what it means to be an intercept form. These are x-intercepts, which, you know, they're on the graph this way. All right, and as we look at this, we could just look at this. X to the 3rd times x squared is 1x to the 5th. So expectation of behavior is, okay, it ends like this at the ends, but those are arrows. Okay, so this is a regular 0, and then it should end down because it's a odd degree. And then nothing special. I don't care how high you go. These are just sketches, but now you got to watch yourself. I don't care how low you go, but what you'd better do is make this like a parabola here, and then come down a little bit and then shoot through that 0 normally, because none of those had special multiplicities. So that's your job for that one, making a sketch. I don't know if I ignored anything else in the directions. Identify the end behavior, sketch the graph, label your axes. And I did this. That was my, what do the graphs look like as far as end behaviors are concerned. All right. Some polynomials have zeros that contain an imaginary number. We already talked about this when we talked about quadratic formula. This means you will not see them on the graph. They will not be x-intercepts is really what that means. And here's what I already defined what square root of -1 is. It's I. So imaginary roots come in, can everyone say conjugate? Conjugate. Conjugate pairs. Okay, they come in conjugate pairs. Or maybe I'm supposed to put pairs there. Okay, but I'm using that word. If a plus bi is a 0, then a minus bi. Guys, let's sing the quadratic formula again. The opposite of b, it's the very next thing. Plus or minus the square root. And then the square root part is where you could get that imaginary number. So that's why they come in conjugate pairs, plus, minus. The plus minus from the quadratic formula. This should not be rocket science. So 4i, the conjugate pair of that is negative 4i. That's all they ask. Read those directions. Conjugate pair of 2 minus 3i, 2 plus 3i. Negative 4 minus, careful on this one. It's negative 4 minus 2i. This is the only thing that changes, not both. And then this is what I promised for the last few minutes of the video. For each polynomial, determine the degree of the polynomial, find all real zeros, and state the multiplicity for each zero. Then identify my imaginary zeros. Well, here's the imaginary. When I set this equal to 0, I get x squared equals negative 1 root. There you go. There's that I number. So what this means is there'll be no x-intercepts. But I'll show you what might happen. You're not responsible for this, by the way. You are responsible for these. This is a double zero at x, or negative 1 for x. This is a single zero. Ow, I hit that yellow. You do. Okay, x minus 3, that's 3 comma 0. And then this is just the leading coefficient. By the way, leading coefficient negative 3, x squared times x, x cubed, 4, 5. We have an x to the 5th. Okay, so it should be like this. Okay, and then that was too many waves. Sorry about the extra waves in the middle, but that's the ends. That's what they look like. Okay, so I will tell you what could happen, but you don't have to worry about this. You have to worry about this. Negative 1, 0 is a double, and I'll put that as blue so we see that. You got to get this down, guys. Okay, again, what I see in class sometimes is people not focused. It's not going to work. This has got to be, you pick things up and move, and the only way you pick things up is extreme focus and paying attention. But then I don't have this. So how do I make this happen? And what's the deal? You're only responsible for those first ones. So what happens? This bounces here, and it's got to come from up here because of what I just said about the end behavior here. Like right there, that arrow has to go up. But this is a degree 2, 0, so it bounces like a quadratic, like a parabola. And then this is just a regular 0. So I guess it's just going to go straight through. And then what are you supposed to do with this? Well, you don't know this, but it's just like this parabola that doesn't cross the x-axis here. That you knew creates imaginary zeros. Hence, it doesn't have real x-intercepts. So what will happen is you'll have some other turn somewhere. It could be up here. It could be in here somewhere. Or it could be here where it kind of comes back, but then it doesn't cross. So you may see some other turning behavior here or in here, and then comes back up and then back down, or in here that other factor or that other set of parentheses creates, but doesn't create an x-intercept. Again, you are not responsible for showing that. I just wanted to share that for extra knowledge. Oh, hit the wrong thing. Okay, there we go.